Okay, now we want to continue studying for the Unit 2 lecture exam by going over lesson number 5, the Wrath of Vulcan, volcanic eruptions. So in our previous lesson, we talked about what magma was and what would happen when magma hardens at depth and what kind of structures it would form. Now we want to see what's going to happen to this magma when it comes up to the surface of the Earth and makes lava, and then what kinds of surface features will it form. So all of this is going to be found in Chapter 5 of your textbook. And let's start by talking about what viscosity is. So viscosity is going to be how sticky a material is. The more sticky the material is, the less likely it's going to want to flow. So let's take a look at something that is not viscous, and that would be water. So that's the blue substance in that picture. So notice that when you pour water out, it's very runny. So it's not viscous. On the other hand, look at the brown maple syrup. When you pour that out, it flows very slowly because it's sticking to itself and it has a high viscosity. And it all comes down to what are the molecules of the substance doing. So on an atomic level, the molecules, if they're sticking to each other, then that's going to enhance the viscosity. So what determines what kind of igneous feature are you going to end up with? So another thing that's going to determine it is going to be temperature. So again, let's look at maple syrup. Cold maple syrup is not runny. It's very sticky and it runs very slowly. If you heat up maple syrup, then it becomes runny. So as you increase the temperature, then that is going to decrease the viscosity of a lava. Okay, it also depends on what is it made of. So what's the lava going to be made of? So if it has a lot of silica in it, then that's going to increase the viscosity. Because imagine that you've got a silica tetrahedron over here. So these are those fundamental building blocks of the silicate minerals. And then let's say that you've got another one that's over here. Then what's going to happen is they want to stick to each other. So that these oxygens are going to see the silicon over here and they're going to want to attach to it. So that these silica tetrahedrons are going to attach, and then that's going to make that particular kind of lava more viscous. So if you increase the amount of silica inside of a magma, that's going to increase its viscosity. Now, if it has gas in it, if the lava has gas in it, that decreases the viscosity, because what will happen, so let's say that one kind of gas that's in magma is carbon dioxide. So if it has carbon dioxide, can you see that that gas would push apart those silica tetrahedrons so that they don't have a chance to hook up to each other? So that the larger the amount of gas that's inside of a magma or a lava, that's going to decrease the viscosity of it. It also is going to depend on its pressure. So that if you increase the pressure of a gas, that's going to make the eruption more explosive. So what are some things that a volcano produces? So one, it's going to produce lava, and there are going to be different kinds of lava. So I have written here the different kinds of magmas that are going to turn into the different kinds of lavas. So when you're in the asthenosphere, the original material is going to be ultramafic. Now this ultramafic stuff normally doesn't make it to the surface, because by the time it goes to the surface, it will have changed into these other kinds of stuff. So we normally do not refer to ultramafic magmas. However, we do talk about mafic magmas, and we do talk about mafic lavas. So the mafic lava is going to be a basaltic. So this one here is going to make a basaltic kind of lava. It's going to have very little silica, which means it's not going to be very viscous, which means it's going to be runny. And that means that it's going to be fast. So when it comes out of the volcano, it's going to flow down the sides of the volcano very easily because it's not very viscous. Another thing that it makes is lava tubes. So be able to recognize a picture of a lava tube. Be able to know the difference between Pahoehoe lava and lava. Also know what a pillow basalt is, and also know what columnar jointing is. All right, then you have your andesitic lavas. So that goes with the intermediate magmas. So I'll put A for andesitic. So that when you have intermediate types of magmas, that's going to produce andesitic types of lavas. The intermediate has more silica than what the mafic did. So that means that more silica means it's sticking together. So it's going to be more viscous. It's going to flow slower. It tends to make mounds when it comes out. So it doesn't tend to run on the surface of the earth. Instead, it just tends to mound up wherever it comes out of the volcano. Big blocks of it tend to break off and then roll down the sides of the volcano. So it makes blocky lava. Then you have rhyolitic lava. So rhyolite goes with the felsic. So this is going to, the felsic magmas, which makes the rhyolite lava, rhyolite rock that comes from the lava, is going to have the most amount of silica. It's going to be the most viscous. It's going to be the type of lava that runs the slowest. As a matter of fact, it really doesn't even run on the surface of the earth. It just tends to mound up. Okay, one of the things that it tends to make is domes. So like for example, when Mount St. Helens exploded and afterwards inside the crater of the volcano, the ground started to rise up, and that was due to the rhyolite underneath it that was pushing it up. Also tends to make spires. So these would be good pictures to be able to recognize for the exam. Okay, another thing that a volcano can produce in addition to lava is going to be gases and aerosols. So you got to know what gases come out of volcanoes. So it's going to be water gas, carbon dioxide gas, and then sulfur dioxide gas. So all of these different gases come out of volcanoes. Also, you have liquid droplets of materials, which is going to be called aerosols. Another thing that gases produce in the lava is holes. So if you've got a, this occurs quite often with mafic, basaltic type lava, that as the gas is escaping the lava, it makes holes. And so that makes that vesicular texture in scoria. Okay, so we've got lava that comes out of a volcano. We've got gases and aerosols that come out of a volcano. And then a third thing that comes out of a volcano is going to be debris that's flying through the air. So in our previous lesson, we called that pyroclastic. Another name for this is going to be tephra. So it all depends on the type of lava. So if you've got basaltic lava that is coming out of the volcano, it's going to make very gentle materials that come out. So you got lava fountains, you've got lapilli, which is going to be little pieces of glass and scoria that are flying through the air. But then you can also have big globs of basaltic lava that hardens and turns into a bomb. And then you can also have blocks that can come out as well. Okay, then you can have andesitic and rhyolitic pyroclastics. So these are going to be the materials that fly through the air, and they come from an eruption of either the felsic or the intermediate type of materials. So you can have rocks that are essentially explode and turn into glass shards, which is going to be ash. And then that ash, when it settles down onto the surface, that's what's going to turn into tuff. So ash is a powder in the air. When it comes back down to the ground and it makes layer after layer of ash, that can be cemented together or heated and melted together to make tuff. You can also have pyroclastic flows. So this is very important. They're incredibly hot, and notice they travel at about 200 meters per second. So you cannot outrun a pyroclastic flow. You can't outdrive a pyroclastic flow. So they're very dangerous. They're in the form of a gas, a superheated gas, and as it flows down, it basically incinerates anything that gets in front of it. Okay, then you can also have debris flows and lahars. So this is what happens when you take the ash and the rocks and stuff and you mix it with water, and it becomes a mud. So as that mud flows down the volcano, that's a debris flow. And if it's really, really runny, then we refer to it as a lahar. Okay, so let's take a break, and when we come back, we're going to start talking about these surface features.